Hey guys, Mrs. Dan's here. So we're on lesson 3 of our statistics unit. I'd like you to try to do now before you watch me do it. And there's just some reminders that you have to put the numbers in order. Make sure you write down that 5-number summary. And I'm asking you not to draw the box plot yet, because there's actually another part of Box and Whiskers that I want to show you today. You need to check yesterday's homework answers. Make sure you have that down before you continue watching this video. And today's objective is that we're going to be calculating outliers. And we're going to learn how to use our calculator. So please make sure you have your calculator out and handy. So if you need to pause to go get your calculator, please do that now. So when we're doing a box plot on our own, you have to make sure your numbers are in order. So I already did that. And then the 5-number summary, 1, 2, 3, 4, 5, 6, 8, 9. There's 10 numbers. So right in here is the median. The median is between 80 and 83. If for some reason you can't do this in your head, remember you could always just add up 80 and 83 and divide by 2. And let's try that again. 80 plus 83. I need to hit enter on mine and then divide by 2. My calculator just divided the 83 by 2 instead of the answer by 2. So it's 81.5. And then the lower quartile comes from this lower set of data. Now there's 5 numbers here, so I could see that the first quartile is at 78. And I could see that the third quartile is at 89. By looking at these numbers, the minimum number is a 25 and the maximum is a 99. But in the objective it said that we're going to be talking about outliers. And outlier is a number that's just very, very, very far away from the rest of the numbers. So by looking at this data, maybe 25 is an outlier. So mathematicians always need to come up with some kind of rule about how you find certain things. So we have to decide if 25 is really far away or not. Like, what makes it too far away? And so that's what we're going to learn how to do today. And actually, your calculator does it for you. So I'm not usually one that says go straight to your calculator. But to be honest with you, with box plots, I always go straight to my calculator. So that's why it's so important that you have it with you today during this lesson. In order to find an outlier, you first have to know what the interquartile range is. Your calculator doesn't tell you the interquartile range. You have to know what it means. So it tells you here that it's the difference between the lower quartile and the upper quartile. Really, when we find the interquartile range, we do Q3 minus Q1. Remember, upper quartile is Q3 and lower quartile is Q1. So to find the interquartile range of this data, we'll do 89 minus 78. And it makes sense to me that it's called the interquartile range. You know that the range is just the highest number minus the lowest number. So the range of this data would be 99 minus 25. So an interquartile range is the upper quartile minus the lower quartile. So we wind up getting the interquartile range is 11. There will be questions on tests about what is the interquartile range. And now an outlier is a number that's, like I said, really, really far away from the rest of the data. An outlier could be an extra low number or it could be an extra high number. There can actually be more than one outlier. So what mathematicians have decided is that if it's more than 1.5 times away from the interquartile range, then it's too big or it's too small. More than 1.5 times away from the more than 1.5 times the interquartile range makes it too far away. So what is 1.5 times 11, since that's what our interquartile range is? This is 16.5. So if the number is 16.5 lower than the first quartile, it's too far away. And if it's 16.5 higher than the third quartile, then it's too far away. So the first quartile is 78. Let's take away 16.5 from that to see how low it's allowed to go. So 78 minus 16.5 is 61.5. That's the lowest a number can be. If it's lower than that, then it's considered an outlier. The upper quartile is at 89, and it can go 16.5 higher than that. So 89 plus 16.5 is 105.5. So a number can go up to 105.5. If it's any higher than that, then it's considered an outlier. So our max number we said was 99, and it's within this highest range. So 99 is not an outlier. The lowest the number is allowed to go is 61.5 before it's considered an outlier. So 25 definitely is an outlier because it's way lower than 61.5. Now there's a chance that there could be two outliers down in the lower range. So I'm going to look at the very next one. It's a 77. That's okay. 77 is within that rule about what makes something an outlier. So 25 is an outlier. So when we do a box plot with an outlier, we actually don't connect the whisker to the outlier. That's how we can visually see if something's an outlier on a graph. So let's plot this information. 78, 81.5, and 89 give me my box. I'm going to plot the lowest number and the highest number. This whisker can go to the highest number because it's not an outlier, but it can't go to that lowest number because it is. So we actually plot the next lowest number, which is 77. And connect the whisker to that and leave this point floating out here. When you see a point floating out there, you know it means it's an outlier. And now I told you that we were going to see how to do this on our calculator. So take those calculators out. And this is where we have some new information to learn on our calculator. We haven't done statistics on our calculator. So I learned how to use my calculator just by fooling around with it, looking at the buttons and seeing what makes sense. Do you notice this button here, stat? That means I could do some statistics in there. Do you notice in blue above my y equals, it says stat plot? It means I could do some statistics in there. So try and use like your common sense to help you figure out what buttons to push. First, we're going to push this stat button. And this very first thing says edit. It means we can enter some information. Notice how we get lists. So this L stands for list. We have list 1, list 2, list 3. So certain kinds of statistics use more than one list. Right now, these box plots, we're only using one list of data. So let's enter what they gave us in the do now, in the order they gave it to us even. I just want to erase my marks here so I can see my numbers better, because your calculator even puts things in order for you. So in this list, we're going to hit 79 and then hit enter and see it jumps down. So enter all of the numbers. So I entered all of mine. Something nice about this list, it kind of tells you how many numbers you have entered. Do you see down here? That's your first number entered. If I arrow down, that's my second number entered. So the last number I entered says it's the 10th number. That helps me see that I didn't like miss a number while entering, because sometimes that happens also. So always check and double check. I entered 10 numbers. So far so good. But now how do I turn this into some important information? Well, you know that a box plot is actually a graph. So above the y equals, it says stat plot. I want to plot my box plot. So I do want to do second y equals to get to here. So all year long, I keep on telling you, make sure your plots are off. Make sure your plots are off. Well, guess what? Now we're going to turn something on. So we're only doing one plot, so I'll turn the first one on. So just hit enter. And now we're at plot 1. I need to turn it on, so I'll click so that the on is highlighted. Now there's different types of graphs that this calculator will do for you. Do you notice these two at the bottom? They both look like box plots. Take a look at this first one now. See how there's some points floating out to the side? That means the first one will tell you if there's an outlier. This second one won't, so don't choose that one. We always need to know if there's an outlier. So you just have to arrow down to type and arrow to the right to sort through all of these. So I want to choose the one with outliers, hit enter so it's highlighted. Notice they tell me that the numbers I'm using come from L1, which is good because that's where I just entered it. And this is the type of mark they're going to put on my graph. I usually just leave it as that. So now I want to see this graph. So remember how I tell you that I hate just hitting graph? I always like to go to zoom. And that's because if I hit graph right now, don't do it, I'll show you though, I still have like a set of axes that I've been like graphing lines on and parabolas on, and I don't see my statistics graph. That's because I didn't put it in the correct kind of window. So you want to hit zoom. And you want to read these. Again, make sense of everything. I've been telling you use zoom standard because it's the standard graph. It goes up to 10 and negative 10 on both the x and y axis. But let's arrow down and notice number 9 says zoom stat. See the stat? This is how I can graph statistical graphs. So again, anytime you're going to graph, I suggest you always go to zoom and pick out of the list the thing that makes sense with the type of thing you're graphing. I'm graphing statistics. I'm going to pick number 9 and hit enter. And there I go. Take a look at this box plot on my screen compared to the one we just did. It looks pretty similar to me. I have a number floating out here. This first whisker is so small I can hardly see it. Okay, but it's really hard to copy this information onto a number line. Look, they don't have it labeled or anything like that. This is just a nice visual for you to see if you did it right. But what I want to do is trace this. The trace button will see it puts the cursor on a part of the box plot. It's telling me that the number it's on right now is 77. And oh yeah, isn't that this number that I attached my whisker to? I told you we didn't want to use the lowest one because it was an outlier. Let's arrow over to that outlier. See, it's a 25. So when you see a point floating out in space, you know it's an outlier. You don't have to do the calculations that I did up here, the 1.5 times 11. I would just skip that. I would go straight to my calculator, and if there's a point floating out, you know it's an outlier. Trace it so that you can see what number it is. So 25 is an outlier. Let's arrow over again. That's the 77. Arrow again. That just landed on that first line of the box, which is quartile 1, and notice it's labeling it Q1 is a 78. The median is 81.5. Q3 is 89. And the maximum number that we actually attach the whisker to is 99. How cool is that? The next thing I want to show you is the 5-number summary. Instead of as a picture, it lists it for us as a list, the way that we like to do it. Let's hit the stat button again. And remember, when we are figuring out medians and quartile 1 and quartile 2 on our own, we're doing some sort of calculation. So it makes sense to move over to this calc. And then take a look at this list of information. The first two things have the word stat next to it. This one var stat and two var stat. Var stands for variable, or how many variables are in the kind of graph that we're doing. How many lists, really, maybe I should be using the word with. This has one list of data, and we put it, they called it like the X values. And number 2 is if you have 2 lists of data. We will be doing some statistics that uses 2 lists of data, but we're not there yet. We're on one list of data, so we're going to stay at number 1 and hit enter. On my screen it says 1 var stat, but it doesn't give me any information, and that's because I want to hit enter one more time, and it's telling me some important information. X with a bar over it stands for the mean. It means if you add up all the numbers and divide how many there are. So it's telling me that the mean of the numbers is 78.8. You've seen me wear a shirt before with this symbol here. It stands for the sum of the numbers. The sum of all 10 numbers that I entered is 788. This is the sum of the numbers squared. This stands for standard deviation. We will get to that in this unit, but we're not there yet. So far all of this information we haven't used with box plots. But notice n equals 10. It tells me that there are 10 numbers in my list of data, and do you see this arrow down? It means there's more information for them to tell us. So when we arrow down, you can see that the lowest number is a 25, quartile 1, the median, quartile 3, the maximum. In this list, though, it doesn't tell me there's an outlier. So the way we see our outliers is by looking at the graph and seeing if there's a point that doesn't have a whisker attached to it. But so I would definitely just use my calculator to do box plots. On part 2, 3, and 4 of your tests and of a Regents exam, you must show some sort of work. So you can't just do a box plot without listing some information. If you enter it into your calculator and copy this list of information, there's your work. You're telling me now that you can do a box plot because you know this information. So always when you're using your calculator, you have to copy some information from your calculator onto your paper in order to count it as work. This next page just tells you everything that I just taught you. So now this is just practice. I'm going to do a little bit with you, but your homework really is to just finish. So identify the first quartile. So you could do this by hand if you wanted to. Put all the numbers in order, find the median of the lower half of the data, or you can just enter this straight in your calculator. Let's do practice one more time. We go to Stat, we go to Edit, and then here's something I want to teach you on your calculator. How can you clear out all of this data quickly? I want you to arrow up so that L1 is highlighted, and I want you to hit clear. Please don't hit delete. If you delete your whole L1. You won't have an L1 anymore. Hit clear and then enter, and it clears all the information that was in L1. I'm going to tell you that the easiest way of fixing a mistake if you accidentally delete your L1, I would just reset the calculator. Maybe that's something I should show you here also. In blue above the plus sign, You see MEM, you can do second, MEM, and see number 7 resets. You could go to reset. Let's reset everything. And it's asking you if you're sure you really want to. I'd say yes. So I hit number 2, and now it's cleared. And now I'm completely reset. I'm back to factory settings. So if by accident I deleted my L1, like if I hit delete, see how my L1 is completely gone? If I reset it, my L1 is back. Okay, so in case you accidentally delete it. Anyway, we're going to enter this data. So I entered everything. There are 12 numbers in this list. I got up to the 12th number on my calculator, and the question is identify the first quartile. So remember, you can graph it, hit trace and see your first quartile, or you can hit stat, calc, 1var stat, enter, and arrow down, and you can see that the first quartile, Q1, is 25. Here they're asking for the upper quartile, but they're just giving you a picture. So remember that this first line is Q1. This is the median. This is Q3. Since the whiskers are attached to all points, there aren't any outliers. Upper quartile means like the higher numbers, so that's your Q3. It looks like it's at 82, so choice 3. Interquartile range. Remember, your calculator doesn't tell you the interquartile range, but your calculator will tell you what Q3 is, and your calculator will tell you what Q1 is. The interquartile range, you can use IQR, interquartile range, remember, is defined as Q3 minus Q1. So I'm going to have you do that on your own. You're going to enter the numbers, you're going to find Q3, Q1, and subtract. Let's go to number 4. So these are 2 box and whiskers. Sometimes I put 2 box and whiskers on one number line to help make some kind of comparisons. I can see that Class A seems to be a little more spread out, right? It goes lower and almost as high as Class B. So we're going to have to go through each one of these statements to see which one is false. So the interquartile range is greater for Class A than Class B. Well, an interquartile range means you subtract Q3 from Q1. I can just see visually that Q1 and Q3 are farther apart from each other in Class A than they are in Class B. So when I subtract, Class B will definitely be a smaller number than Class A. So the interquartile range is greater for Class A than Class B. That is a true statement, so it's not the answer to this question. The second quartile, second quartile, what we've been calling it is the median. So they're talking about the median. The second quartile is higher for Class B than for Class A. So remember, the median is this middle line of the box. Class B's middle line is higher on this number line than Class A. So Class B's median is greater than Class A's median. So this is also another true statement. The lowest score was in Class A. Class A's lowest score is here, while B's is here. Class A is lower. That's a true statement. So I guess it must be choice 4. Let's take a look. Class A did better than Class B. So there's a few things to look at. I guess these are test scores. Yep, I didn't read that. Test scores for 2 classes. Class A didn't do better. Class A had a way lower score than Class B. Class B's highest score was higher than Class A's. More of the scores were at the higher end. We can say that 50% even, right? 50% is from the median up. 50% of the class is like equal to only 25% of 50% of Class B's scores are about the same as only 25% of Class A. So Class A did not do better. So choice 4 is the false statement. In number 5 and 6, I would enter this into the calculator and then construct your box and whisker. Be careful, check and see if there's an outlier on your graph of your calculator. Remember, a point floating out there. This way you don't connect a whisker to it if there's an outlier. Number 7, they're telling us that the interquartile range is 18, and they're telling us that the first quartile is 52. So they're asking what value could be the median. So let's use like some common sense here. Remember, interquartile range is Q3 minus Q1. So I can actually find what Q3 is. If I know the interquartile range is 18, I don't know Q3, but they told me that the first quartile is 52. I can see that quartile 3 must be 70, right? 70 minus 52 is 18. So the median, I don't know exactly what the median is, but the median has to be between 70 and 52, because this is quartile 3, this is quartile 1. The median comes between the two of them. So it can't be choice 1, it's too low. Can't be choice 2, it's too low. Could be choice 3, and it can't be choice 4, it's too high. So the choice is choice 3. So do you see you have to use like some common sense, which really is logic skills in mathematics. Number 8 and 9, you're doing a box plot again. Check for those outliers. Number 10, in a box and whisker plot, what percentage of the scores are represented by the box? So let's talk about a box and whisker again. It's what we talked about yesterday, where it's separated into 4 pieces. This is 25% of the data. This is 25% of the data. 25% of the data, and 25% of the data. So in a box and whisker plot, what percentage of the scores are represented by the box? So from here to here, 25 and 25 must be 50%. In a box and whisker plot, what percentage of the scores are represented by each whisker? This whisker has 25%. This whisker has 25%. Each whisker shows 25% of the data. In a box and whisker plot, what characteristics of the data would position the median in the middle of the box? So where I drew my median, it's slightly to the left side of the box. They're asking what would make it right in the middle. Well, the median would have to be exactly halfway between the lower quartile and the upper quartile. If the median is exactly halfway between the upper quartile and the lower quartile, it actually means it's like the average. The average is the mean. Is it possible to have a box and whisker plot with only one whisker? And that is true. It almost happened on this question, right? This number was just one lower than the lower quartile. So what if like we had that outlier and the next number was 78 instead of 77, I wouldn't have a whisker, right? It would wind up being just a one whisker box plot. There are many ways that it can happen, so different answers will be acceptable, but it is possible to have only one whisker. Number 14. So we have to use our logic skills. They're saying that there are two different box plots, and they have the same extremes and the same median. So that line going down the box is in the same position, and the whiskers, I guess, are going out to the same spots. However, the box is twice as long for the first plot as for the second. So let's draw something that could possibly represent this data. So if I have a box, and let's say, this is the median, and let's say the whiskers go out to here. The next box is going to have the same median and the same extremes, but the box is way smaller. So visually, since each piece represents 25% of the data, it really means in this first one, the data is so far more spread out, right? Like 25% of the data is in here, but those numbers are further apart from each other than the 25% of the data here. These numbers have to be so close together. It's like they're all clustered around the median. Like the numbers are so tightly grouped in this second box and way more spread out in this first one. So that's why a box plot is an important statistical measure. Visually, we could see that these numbers must be way more spread out than these numbers. These whiskers are very long, which means a lot of the data is close to the median, but of course there is 25% of the data that spreads out to the upper extreme and 25% of the data that spreads to the lower extreme. So I guess these numbers are more spread out, but right around the median, the numbers are very close together. And then I think you can finish the rest on your own and check back for the answers tomorrow. I will talk to you soon. Send any questions my way, please. See ya. Bye.